The stars that shine above us tonight are not eternal, nor are the galaxies that cradle them, or the atoms that comprise them. In time, all things decay, all structures dissolve. Even light, which once seemed the very signature of permanence, fades into silence. This reality is neither poetic exaggeration nor myth. It is the consequence of physics, relentless in its patience and merciless in its symmetry. Yet when we speak of death, we usually speak in the language of the living, of endings, of silence, of the abrupt departure of motion. But what does it mean for everything to die? Not a person, not a species, not even a star, but everything. The totality of being. The whole cosmos. What happens when the last light flickers out? When even the concept of time becomes useless because there is nothing left for time to change? To answer this, we must journey far beyond the boundaries of our experience. We must walk the corridors of time as they stretch into the unimaginable future and draw on the deepest insights of thermodynamics, quantum mechanics, general relativity, and philosophical speculation. The answers are not all known, and some may never be, but the contours of the question alone are enough to unsettle even the most stoic mind. The universe began, as far as we can tell, in fire. The Big Bang, nearly 13.8 billion years ago, was not an explosion in space. It was an explosion of space itself. From a singularity or something near to it, space-time unfurled. Matter and energy condensed. In the first microseconds, the fundamental forces separated from one another. Time itself began. Hydrogen and helium coalesced from pure energy, forming the first building blocks of stars. Stars ignited. They fused lighter elements into heavier ones. They died and scattered their ashes across the cosmos. Those ashes became planets, people thought. And yet all of this is ephemeral. Our era, this moment in which stars still shine and galaxies still churn, is not the rule. It is a brief chapter in an immensely long story. In fact, it may be that we are living in the universe's early spring, destined to fade into an autumn of entropy and a winter of darkness. To understand the death of everything, one must understand entropy. Entropy is the measure of disorder in a system. More precisely, it measures the number of microstates compatible with a macrostate. How many ways the pieces of a system can be arranged while still appearing the same on a large scale. In thermodynamics, the second law tells us that entropy always increases in a closed system, and the universe, as far as we know, is the ultimate closed system. This means that over time, all systems will evolve towards states of higher entropy. Stars will exhaust their nuclear fuel and become white dwarfs, neutron stars, or black holes. Gas clouds will dissipate. Planets will be consumed or ejected. Even black holes, once thought eternal, will radiate away their mass via Hawking radiation, a slow process, taking longer than the age of the universe to observe. In the end, all structures break down. But what does this look like in practice? Imagine the distant future, trillions of years from now. Most stars have long since died. Only the dimmest red dwarfs still flicker weakly, their hydrogen fuel burning with glacial slowness. No new stars form, for the gas that once birthed them has been used up or scattered beyond usefulness. The galaxies, once bright cities of stars, are darkened ruins. Eventually, even the red dwarfs fade. The universe is now populated primarily by stellar remnants, white dwarfs, neutron stars, and black holes. But these too are not immune to time. White dwarfs will eventually cool and crystallize into black dwarfs, frozen lumps of carbon and heavier elements, utterly dark. Neutron stars, those ultra-dense corpses of massive stars, will persist longer, but even they may decay or be disrupted by collisions over cosmic timescales. Black holes reign supreme in this era, the so-called black hole era. These titans consume matter and energy, yet they are not immune to loss. Due to quantum effects near the event horizon, black holes emit Hawking radiation, slowly losing mass. The larger the black hole, the slower this process. A stellar mass black hole might take 1067 years to evaporate. A supermassive black hole, like the one at the center of our galaxy, might take 10 to 100 years or more. Yet even these monsters eventually vanish. What remains after that? Radiation, sparse particles, a nearly perfect vacuum, a state some physicists call heat death, or the big freeze. The universe will have reached maximum entropy. There will be no usable energy left to do work. No gradients, no structure, just an expanding void filled with thin, cold radiation and scattered particles drifting through infinite silence. And yet some have proposed even more dramatic endings. The Big Rip, for instance, suggests that if dark energy increases over time, a possibility consistent with some interpretations of data, it could tear apart galaxies, then solar systems, then atoms themselves. Space-time would stretch faster than light can travel, breaking all bonds, disintegrating all structure, until even the fabric of the cosmos is shredded into nothingness. Another possibility is the Big Crunch, a reversal of the Big Bang in which gravity ultimately overcomes expansion and the universe collapses back into a singularity. However, current observations strongly suggest that the universe's expansion is accelerating, making a crunch increasingly unlikely. Then there's the concept of vacuum decay, a quantum event in which a more stable form of the vacuum emerges, expanding at the speed of light and obliterating the known laws of physics in its path. In this scenario, we might not even see the end coming. One moment, stars shine. The next, the rules of reality change and everything is gone. Still, for all these endings, the deepest question remains: if everything dies, what remains? Here, science touches the edges of philosophy. If entropy reaches its maximum and no change is possible, does time itself cease to have meaning? After all, time is defined by change, by the distinction between what was and what is. In a completely uniform state, without difference or motion, is there time? Moreover, what is the ontological status of a universe in which nothing happens? Is being without becoming truly being? Or is it a kind of metaphysical death, a silent nullity that no longer qualifies as real, in any meaningful sense? Some thinkers have posited that the death of everything is not the end, but a transition, that from this stillness something new might emerge. Just as the quantum foam from which the Big Bang was born may have emerged from a prior nothing, so too might new universes arise from the ashes of this one. In some versions of cosmology, black holes themselves may be birthplaces for new universes, a thickened multiverse eternally budding from its own entropic decay. Others invoke the anthropic principle. We live in a universe capable of supporting life because life exists to observe it. There may be countless other universes where nothing interesting ever happens. If that's the case, then the death of our universe is just one note in an eternal symphony, most of which we can never hear. Yet even here, there is a peculiar sadness. The end of everything includes the end of observers. There will be no one left to see the last star die, no eyes to watch the last black hole evaporate, no mind to contemplate the silence. The universe becomes not merely dead, but blind to its own death, a book with no reader, a poem that erases its own meaning as it ends. This, perhaps, is the most haunting thought of all. That everything we are, everything we build, everything we remember and hope for, is confined to a fleeting window in an indifferent cosmos. That our libraries and music and love and suffering will all dissolve into atomic dust and then into unknowing nothing. That death comes not only to the individual, but to the totality of being. And yet, this very knowledge gives life a kind of tragic nobility. Knowing that the flame will go out does not make the flame meaningless, it makes it precious. Finite time is not a curse, but a crucible. From it we draw urgency, creativity, tenderness. We build cathedrals not because they will last forever, but because they matter now. If the universe is a brief flash of light in a sea of eternal darkness, then all the more reason to look closely at the light. To love the stars not for their permanence, but for their brilliant impermanence. To embrace each moment not as a static bead on a necklace of time, but as a firework that flares and fades, beautiful precisely because it will not last.